You are welcome to the GMAT 41's channel. In this video, we are going to give attention to past questions, solutions, and answers on indices, mathematics. This is actually on Math 101, elementary mathematics. Is that okay? And these questions are those extracted from 2017 to date. We are just simply going to see how we deal with these questions if we are to be in the examination hall. It's past questions and answers. Is that okay? So follow up, we have our first question here. Solve for x and y in the equations 2 to the power of x plus 2y equal to 2. And then we have 3 to the power of 2x minus y equal to 27. We have the options here as usual. We have to solve for x and y. So what do we do? Simply, if you look at this is simultaneous equation clearly. This is equation 1, this is equation 2. So attacking straight, here you have just one term on the left hand side. On the right hand side, you have one term also. Now, the term you have here, the base is 2. On the right hand side, the base is also 2. So you can cancel out the bases. Are you following, right? This 2 is raised to power 1. If you cancel the bases, you are going to get that x plus 2y. That is, equate their powers. X plus 2y will be equal to power 1, alright? And we'll call this equation 1. Similarly, when you come to this part of equation 2, now the left hand side, the base here is 3. The right hand side, the base is 27. What we have to do is to break down 27 to base 3. And to achieve that, this 27 is the same as 3 raised to the power of 3. Take note, 3 as a base, raised to power 3 will give you 27. Now, if I express here as base 3, the power is 3 like I said, here is base 3, the bases will cancel. Then you equate their powers, which means this is going to give us 2x minus y equal to 3. This is equation 2. So solve this equation 1 and 2 simultaneously. And to do that, you have your choices to select from. You can solve using elimination method. You can also solve using substitution method. The choice is yours. But I always prefer using elimination method where I apply one knowledge, okay? I'll just mention it, but don't bother yourself about it. It's still extension of elimination method. Talk about the echelon method of solving this. Now, like I said, I want to eliminate x. And to achieve that, I would have to make the coefficient, what is multiplying x in equation 1 to also be 2. Which means I will multiply all equation 1 by 2. If I do that, immediately I will subtract equation 2 from whatever I get. So we proceed. 2 times x will give us 2x. 2x minus 2x is 0. You have kicked off that x. Then come to this y. 2 times 2y will give you 4y. Then 4y minus the y that you have in equation 2. But this y you have in equation 2 has minus in it. So it's going to be 2 times 2y from equation 1, which is 4y, minus y, which automatically becomes plus y. 4y plus y is going to give us 5y. So this is 5y. Alright, then move to the right hand side, multiply this one by 2. You have 2 times 1, which will give you 2 minus 3. 2 minus 3 is going to give you minus 1. Therefore, you would see that y is equal to minus 1 over 5. So now that I have obtained the value of y, I'll simply use that to get the value of x. To do that, I can use any of these 2 equations, but you want to apply wisdom if you're in exam how to decide the equation to use to get your x. For me, I prefer equation 1 because it contains terms that are smaller in value, okay? It's not a rule anyway, but just for it to be fast. So, substitute this minus 1 over 5 for y in equation 1. That will now imply that you have x plus 2 bracket minus 1 over 5. I've substituted for y here, and that's going to be equal to 1. Solving for x, you have x, this 2 times minus 1 over 5 will give you minus 2 over 5. If this plus multiplies this minus, it gives you minus. And that's going to be equal to 1. You can clear your fraction or collect like terms, the choice is yours. The LCM of this guy is 5, so use that 5 to multiply all the numerators. It's going to be 5 times x minus that 5, if it multiplies this 2, the 5 will cancel this denominator, you'll be left with 2, and then 5 times 1 will give you 5. Collect this minus 2 to the right hand side, you're going to get plus 2 there, which is going to be 5 plus 2, giving you 7. Automatically x is equal to 7 all over what? 5. And of course we are done. This simply means that the value of x, y is going to be equal to 7 over 5, minus 1 over what? 5. So come over here. If you see the options that agree with this, fine, you select it. If you do not see it, it means that the answer is not there. Of course, from what I'm seeing here, the correct option is not there. Option E is not. That is none of the above. And of course, that is also part of our options when it becomes necessary, like this case. Yeah. What we got here for value of x and y is not in the options. So none of the above goes. We're going to move on to our second question. We've got our second question here. Simplify 8 to the power of 1 minus 8 to the power of minus 1 over 3 plus 8 to the power of 0. Sometimes when something like this is given, it can be quite scary. You know, just be wondering what actually they want us to do. Relax, just apply the normal knowledge you know about indices. So if you've studied indices as a topic very well, you'd see this is 1 plus 1. And we're going to find out, okay? If you are given 8 to the power of 1, you agree with me, it's simply going to be what? 8. Okay, so this is going to be equal to 8 to the power of 1 is 8. A number to the power of 1 is that number. Then coming here, you have 8 to the power of minus 1 over 3. Before that, you have minus here anyway. Now, because this 8 has a power, and that power is a fraction. So the power is not 1, it's not 0, like these ones. These ones are just simple to play with. This one also is simple anyway, but you are going to be guided by something. This is a fractional power, and the denominator is 3. So you have to find a way to break this base 8 to something that will have power 3. So that possibly that power will clear this denominator 3. Are you following, right? Yeah. And we can achieve that. This 8 as a base can still be written as 2 to the power of 3. And then I'll work it out for you to see. 8 to the power of 0 will give you 1. A number to the power of 0 most generally is 1. Okay? Then coming over here, you can add this 8 and 1. Using board mass, okay, go with the positive first before you talk about the negative. And of course, that's going to give you 9. Then watch. This power 3 and power minus 1 over 3, you apply power law of indices to them, multiply the powers. And if you multiply these, you agree with me that this 3 will cancel this 3. So that this will be left with 2 to the power of minus 1. 2 to the power of minus 1 is the same as 1 over 2. Using negative index law of indices, converted to reciprocal. So this is the same as minus 1 over 2. Work out the LCM of this. If you do that, this is what you're going to get. Use this denominator 2 to multiply this whole number 9. You get 18. Minus 1, you get 17 over 2. So the solution to this indices term here is 17 over 2. Looking at the option, the correct answer is C. We shall be moving on to question number 3. But remember what I said, if you are still having problems in indices, consider taking the tutorials, okay? And here the GMAT 41 has that for you. Become a channel member, just click on the Join tab below this video, select the Platinum Levels package, and then you can get access to the full tutorial on indices and indicial equation. Question number 3. Solve for y in 6 to the power of y times 3 to the power of 2y times 4 to the power of y times 3 to the power of minus 2 times 4 to the power of minus 1 equal to 6. So we have to solve for y in this indicial equation. Once again, it's a simple one. Now what we are going to do is to look at this properly and see how we can break all these numbers that we have on the left hand side to have, common base, which are prime numbers. And when you are breaking this down, you look at which one is the smallest prime numbers you can obtain from them. So you walk towards that direction. Therefore, this 6 you are seeing here raised to power y, 6 can be broken down to 2 times 3 because the smallest prime number we'll have here is 3. So we're going to target that 3. 6, I'll rewrite this as 2 times 3. Then everything raised to power y. And if I have 2 times 3 in bracket raised to power y, we can apply the distributive law of power. Are you following, right? So that 6 is the same as 2 to the power of y times 3 to the power y. That is what I'm talking about. Okay? That will be multiplied by this 3 down to the power of 2y, and then times 4 here can be broken down to 2 to the power of 2. Now, I have to do that because you can see now that 2 has appeared here from 6. And 2 is also a prime number, Even if it's an even number, it's also prime. So that 4 will be broken down to 2 to the power of 2. That power 2 will multiply that power y that will give you 2 to the power of 2y. and then times that 3 to the power of minus 2 times this 4. I will break it down to 2 to the power of 2. The power 2 will multiply power minus 1 here to give us 2 to the power of minus 2, and everything will be equal to what? 6. At this point, all I have to do is to apply multiplication law of indices, combining the same base, that's picking the same base and adding their powers. I have 2 here, I have 2 here, I have 2 here, base 2, base 2, base 2. So pick one of the base 2, add their powers, times pick one of the base 3, do the same thing to their powers. That's going to be equal to 6. If you notice, their powers are the same now. So what do? Kind of factorize the common powers and then combine the bases. I can write this as 2 times 3, which will give me 6. Are you following, right? Because the power is common to both of them, you pull out that power, 3y minus 2. And then that's going to be equal to 6. This 6 is raised to power 1. The base on the left and the base on the right, they are the same thing now, 6, 6. So you cancel them out. And once you do that, you'll be left with 3y minus 2 equal to 1. You equate their powers. From there, solve for y. And if you're solving for this, minus 2 will cross to this right hand side, giving you plus 3. Divide both sides by what is multiplying y, which is 3. Therefore, the value of y for this question is 1. Looking at the options provided, the correct option is what? Option D. We are moving on to our next question, number 4. Here we've got our fourth question. Before we solve this question, please, have you subscribed yet? If you are yet to subscribe to the GMAT 41's channel, what is keeping you? Hit the subscription button, alright? Then like this video. And please do me a favor, alright? This favor is something that could also save someone out there you can never tell. Share these past questions, solutions, and answers. Share it to your friends, to classmates. Like I said, you can never tell. This might just be what they need. Okay? Alright, let us move on to solve this fourth question. We have this indicial equation given to us, a to the power of 2 times b to the power of minus 3 times c, all in bracket raised to the power of 3 over 4, then all over a to the power of minus 1, b to the power of 4, c to the power of 5. And that is equal to a to the power of p, b to the power of q, and then c to the power of r. The examiner requires that we find p plus 2q. So what we do here, it's simple. All we have to do is to simplify this left-hand side so that it will look like the right-hand side. And then we equate their powers. Solution to this question. So the first thing I will do is to distribute this external power, this power outside, distribute it to the powers inside the bracket using power law of indices. And whenever I'm doing that, I would use the powers inside to multiply and then see what I'm going to get. Starting with a, I have a to the power of 2. Now that 2 will multiply 3 over 4. If 2 multiplies 3 over 4, the 2 will cancel this 4 here, so that the 4 will reduce to what? 2. So you're going to have 3 over 2 as the power of what? A. Then times b. Now this b has power minus 3. Use it to multiply 3 over 4. If this minus 3 is multiplying this 3, you're going to get minus 9, then over 4. Okay, then move on to c. The power of c here is 1. 1 times this 3 over 4 will give you c to the power of 3 over 4. And this is going to be all over a to the power of minus 1, b to the power of 4, and then c to the power of 5. We shall equate this to a to the power of p, and then b to the power q, c to the power r. Good. At this point on the left-hand side, I am going to apply division law of indices. You see, because we have similar bases, but the powers, we can work it out. Taking the powers of the denominators up and simplifying, we are going to get a to the power of 3 over 2. This minus 1 will climb to become plus 1. So you have fractional power there, which you are adding 3 over 2 plus 1. And you can work that out quickly. This is going to give us a to the power of 3 over 2 plus 1. So this power a is going to be 5 over 2. Come to that of 9, do the same thing. This 4 will move up. If it moves up, it becomes minus 4. Then working out the LCM is going to be this denominator 4 times that minus 4, which will give you minus 16. That minus 16, add it to this minus 9. Minus 9 minus 16 will give you minus 25. Everything will be all over the 4. So you have, and then we conclude with that of c. 5 will go up to become minus 5. And then you are going to get 3 over 4 minus 5. Work out the LCM. So power c is going to be minus 17 over what? 4. We shall make this equal to a to the power of p, b to the power of q, and C to the power of what? R. Now that you have expressed the left-hand side to look the same way as the right-hand side, we shall now compare their powers and equate them. Is that okay? Now we are looking for P plus 2Q. That's what the examiner asked us to get. So I will be interested in getting the value of P and Q. From here, P is the power of A. So definitely it is equal to the power of A on the what? Left-hand side. In a similar way, Q, which is the power of B on the right-hand side, is going to be equal to minus 25 over 4 on the left-hand side. We were not asked anything about R, so I won't punish myself to say that R is equal to minus 17 over 4. No need. Let us focus on solving for P plus 2Q as the examiner expects us to get. That is going to be P is 5 over 2, then plus 2Q means 2 times the value of Q. And let's do this once and for all, please. Good. Simplify this fraction. The LCM is 2, and so you have your 2 here. That's going to give us 5 minus 25. Alright, if you work out the LCM, and you are going to get minus 10. That's cool. The correct answer to this question is option D. I hope you enjoyed this, right? That's good. We are going to look at our 5th question right now. So we have question number 5 here. We are asked to simplify 75 to the power of n times 3 to the power of n plus 1 times 45 to the power of 2n all over 15 to the power of 2n plus 1 times 25 to the power of n times 9 to the power of 2n. Now how fast can you solve this question? Because I won't solve it fully on the board as it is. Okay, so I'm going to tell you one shortest cut of the shortcut, although I've covered all of this in the video lesson on indices and indicial equation. But the shortest cut of solving this problem and the step-by-step approach of solving this, as your examiner might want you to do in normal situation, okay? But we are looking at the fact that you are in examination hall. So to attack this question, all you just have to do, let n be equal to, you see, this is an indicial expression. It is not an equation. It's not equal to anything. Are you getting me right? So since it is just an expression, this unknown you have here, n. N is the same as n. So you can select any value in this word for n. I repeat, n is the same as n. The n you have here is what you have here, what you have here, and the rest of them. So you can select any value for n in this word, and it doesn't change anything. Once you do that, simplify, you get your answer. The best thing to do if you are seated in the exam hall is selecting n to be equal to 0. So if n is equal to 0, come over here, let's work it out quickly. This is now going to be equal to 75 raised to the power 0 will give you what? 1. So we have 1, and then times, fix 0 here, add it to 1, you get 1 as the power of this 3. 3 times 3 raised to the power 1 is going to give us 3. Then come over here, fix 0 here, 2 times 0 is 0, 45 raised to the power 0 is 1. Then we are going to divide all of this by, fix 0 here, 0 times 2 is 0. Add 1 to that 0, you get 1. 15 raised to the power 1 will give you 15. Then times, this is 0, 25 raised to the power 0 is 1. And then we have 9 to the power of 2 times n. Fix 0 here, 2 times 0 will give you 0. 9 raised to the power 0 is 1. And so simplifying this, the numerator will give us 3, the denominator is 15. 3 over 15 will give you 1 over what? 5. So that is the fastest way of solving this particular indicial expression of this type. Alright, it's been wonderful, holding these past questions, solutions and answer section with you, and I hope you learned something wonderful, right? You can actually support GMAS 41 so that we'll continue to grow, to do our best in supporting your studies. And how can you do this? Like I said, just below this video lesson, you have the Join tab. Kindly click on that Join tab, and you can select a package that is convenient for you. We have the gold level, the platinum level, and the diamond level. However, I urge students, to select the platinum's level package, because that will give you access to all the video lessons on the GMAS 41's platform, and even more, all right? Because you can also get more personal assistance from GMAS 41 on that package. And for those in UNIZIC, students of UNIZIC, those in 100 level, you wish to attend physical tutorial, you can always locate GMAS 41 on campus. I have my tutorial venue on campus, and you can join us so that I can also coach you, mentor you physically for you to get the best in your studies also. It's all right. I'll be seeing you in our next video lesson when I treat, episode U04, past questions, solutions and answers on logarithms. Until then, remember to take your studies seriously.